Dear students, we are studying about integration. We find the integrals of the some functions. We already studied about indefinite integrals. We shall solve some other problems on indefinite integrals. Find the integrals of the following. Here, integration of 2x minus 3 cos x plus e to the power x is equal to integration of 2x dx minus integration of 3 cos x dx plus integration of e to the power x dx. Then 2 is constant here. Integration of x is x square divided by 2 minus 3 into integration of cos x is sin x, then plus e to the power x into function 2x minus 3 cos x plus e to the power x. Here we integrate the functions separately 2x and minus 3 cos x plus e to the power x. Then next, second one, integration of 2x square minus 3 sin x plus 5 root x. Here, integration of 2x square dx minus, we can write 2 outside also, x square dx minus 3 into integration of sin x plus 5 into integration of root x dx. Here, 1 by 2, x to the power 1 by 2. Here, 2 into x to the power n plus 1 divided by n plus 1. Here, 2 plus 1 is x to the power 3 divided by 3 minus 3 into integration of sin x is minus cos x plus 5 into x to the power 1 by 2 is plus 1, x to the power 3 by 2. 1 by 2 plus 1 is equal to 3 by 2 divided by 3 by 2 plus c. We get 2 by 3 x cube minus into minus plus 3 cos x plus 2 into 5 10 by 3 x to the power 3 by 2 plus c is the integration of this function. Here we have to integrate the functions which is adding or subtracting. I think you clear about to find the integrals of these functions. Next, we shall go to the next problem. Here, some simplification is there. Third one, integration of sec x into sec x plus tan x. We multiply this one, we get sec x into sec x is equal to secant square x plus sec x into tan x, sec x tan x into dx. Then we integrate sec square x dx and sec x tan x. You already know about integration of secant square x is tan x because derivative of tan x is secant square x. Then sec x tan x is sec x plus c. Because integration of secant square is tan x and derivative of tan x is secant square x and derivative of sec x is sec x tan x. Therefore, we can write the integration directly. fourth one, which is secant square x divided by cosecant square x. We can write in the reciprocal form. Secant square x is 1 by cos square x divided by cosec square x is 1 by sin square x. It becomes 1 by sin square x dx, which is equal to sin square x divided by cos square x is equal to tan square x dx. Therefore, integration of tan square x is, we can't write tan x. I didn't tell about the integration of tan x. Therefore, I translate tan into identity. Tan square x is equal to secant square x minus 1. You already know about the identities. 1 plus tan square x is equal to secant square x. Therefore, tan square x is equal to secant square x minus 1. Therefore, I write it as secant square x minus 1 dx. We can write easily secant square x integration is tan x. Then integration of 1 is x plus c. The integration of cosec the secant square x divided by cosec square x. First we translate it into tan square x form. Then tan square x into identities. By using identities we write it as secant square x minus 1. Then integrate this one, we get tan x minus x plus c. Next, fourth is finished. Fifth one, integration of 2 minus 3 sin x divided by cos square x dx, which is equal to integration of 2 divided by cos square x minus 3 sin x divided by cos square x dx. Then we can write 2 into integration of 1 by cos square x is equal to secant square x dx minus 3 by sin x by cos x, 3 into 3 into sin x by cos x is tan x and 1 by cos x is sec x dx. 1 by cos square x is secant square x, then minus 3 sin x divided by cos square x. Here sin by cos is tan x, then again 1 by cos x is there, it's equal to secant x. Therefore, integration of 2 into secant square x is equal to 2 into tan x minus 3 into tan x into secant x is equal to sec x plus c. 2 into tan x minus 3 secant x plus c is the integration of 2 minus 3 sin x divided by cos square x dx. Next, we shall solve another one problem, which is now we are solving indefinite integrals. The process of finding the integrals of the functions is called integration. Is the method. We solve one more problem, which is sixth one. If d by dx of f of x, which is equal to 4x cube minus 3x to the power 4. Find f of x. Find f of x such that f of 2 is equal to 0. Then find f of x. Here, derivative of the function is given here is 4x cube minus 3 divided by 4x to the power 4. We have to find the function f of x. First we find the f of x by integrating the derivative 4x cube minus 3 by x to the power 4 dx. Here 4x cube minus 3 into x to the power minus 4 dx is equal to 4 into x to the power 4 by 4 minus 3 into x to the power plus 1. It becomes minus 4 plus 1, which is equal to minus 3. Therefore, x to the power minus 3 divided by minus 3. Therefore, we can write this equal to x to the power 4, then x to the power 3 gets cancelled, minus into minus plus 1 by x to the power 3 plus c. Therefore, f of x equal to x to the power 4 and 1 by x to the power 3 plus c is the f of x value. But here given is f of 2 is equal to 0. We substitute x is equal to 2. 2 to the power 4 plus 1 by 2 to the power 3 plus c, which is equal to 2 to the power 4. It's 16 plus 1 by 8 plus c, which is equal to 129 divided by 8. 129 divided by 8 is f of 2. Plus c. Therefore, c is equal to f of 2 is equal to f of 2 is equal to 129 divided by 8 plus c. But here given is equal to 0. 0 is equal to 129 divided by 8 plus c. That implies c is equal to minus 129 divided by 8. Therefore, f of x is equal to, we write, when f of 2 is equal to 0, c is equal to constant value is minus 129 divided by f of x is equal to, here we already write it as x to the power 4 plus 1 by x to the power 3 plus c is minus 129 divided by 8 is the answer. First, we find the integration of the derivative, we get the function. Then we substitute the value of f of x value is 2. Then we get c value, which is minus 129 divided by 8. Then we substitute this one into f of x, so we get x to the power 4 plus 1 by x to the power 3 minus 129 divided by 8 is the function of the this f of x derivative. F of x, which derivative is 4x cube minus 3 by x to the power 4 and function is f of x is equal to x to the power 4 plus 1 by x to the power 3 minus 129 divided by 8. Next, we solve these problems by using the formula and find the integration of this type of functions. But in the complex, if the function is in the complex part, we can't get the function by integrating this type. Is not possible. Therefore, we can use some different methods to integrate the function. That functions are methods of integrations. Methods of integrations. There are three methods. First one is substitution, another one is partial fraction method, and third one is integration by parts. Three methods are there. First method is substitution method. Integration by substitution. Second one is integration by partial fraction. By using partial fractions. Then third one is integration by parts. First one is integration by substitution. If a function is given in, integration is given in f of x dx, we substitute x into another form by changing independent variable x is equal to g of t. Yeah, f of x is the function given. We substitute x is equal to g of t. Another form here, variable is x. We translate this x variable into t. Then we differentiate dx by dt is equal to g dash t. Then dx is equal to g dash t into dt. Then the integration of f of x dx is translated into f of g of t into dt. G dash dx is equal to g dash t into dt. Here the function is in f of x dx is given, but we can't integrate this one directly. We substitute x is the variable here, independent variable is x. We substitute x is equal to g of t, then differentiate x with respect to t. We get dx by dt is equal to g dash t. Then dx is equal to t goes this side, then g dash t into dt. Then the integration of I is transfer is to integration of f of g of t into g dash t into dt. Then we integrate the function. It's the integration by substitution. Next is the integration by partial fraction. Some functions are in x square and x into x plus 2, etc., x plus 3, etc. Then we convert it into some of the other, convert it into some of the fractions, other fractions. This is called partial fractions, some of the fractions. Then we integrate this complicated denominator into simple. Then integrate. Next, third one is integration by parts. Sometimes integration is x square into sin x dx. this type of integration, we can't integrate this function directly. We use by parts, by method of integration by parts. We can integrate this function this time. It's the product of two functions. Product of two functions. It may be inverse trigonometric functions and algebraic function, or algebraic functions and trigonometric functions, or e to the power x exponential functions and integral trigonometric functions, etc. Any type of integration, if it is there, product is there, we use the method of integration by parts. First, we solve the problems on integration by substitution. In substitution, we have to substitute any function per independent variable is converted into another independent variable. Then it convert this one is independent, another variable, then integrate it and again transfer this. First one I will take one problem. Integration of f of sin x sin into mx dx. Integration of sin of mx dx. We already solved the problems like sin x, cos x, or tan x, tan of sec x square x, etc. Integration of sin x, we can write the integration of sin x is minus cos x plus c. This is the derivative of integration. My derivative of cos x is minus sin x, therefore minus cos x is sin x, therefore integration of sin x is minus cos x plus c. But here is it's the complex. Here sin of m of mx is there. We put m into x is equal to t. Put m into x is equal to t. Then m into dx by dt with respect to t is equal to derivative of t is 1. Here we differentiate the function with respect to t, because we put the first independent variable x into t. Therefore, we differentiate the function with respect to t. We get m into dx by dt is equal to 1. Therefore, m into dx is equal to dt. Then dx is equal to dt by m. Then we substitute this in the function. Here it is I. Then I is equal to integration of sin of mx is changed as sin of mx is equal to t into dx. Dx is equal to dt by m. Dt divided by m. Therefore, 1 by m into sin t. Integration of sin t is equal to minus cos t plus c. Therefore, 1 by m minus 1 by m cos t. But here 1 by m into t is equal to mx. Therefore, m into cos of mx plus c is the answer. Here, first we put mx is equal to t. Then m into dx by dt. Differentiate with respect to with respect to t, we get dm into dx by dt is equal to 1. M into dx is equal to dt. This goes this side. Then dx is equal to dt by m. We get integration of sin of mx dx is equal to sin of t into dt divided by m. Then integrate this one. 1 by m is common. Then sin of t integration is minus cos of t plus c. Then we change the